Okay, let's look at number one. Solving log equations, like I said, we're going to be using the properties of logarithms that you learned last week, and also changing it from exponential, or from log form to exponential, which was easy. You'll be fine on this. Let's look at the first one. We have, by the way, I've got all these logs are already the same. To do this, you have to have all the same bases on your logs. Somebody tell me what the bases are on these since it's not there. 10, thank you. Remember, it's base 10, that's our number system. Okay, here's all you got to do on these is, first of all, we need all the logarithms on one side. Remember how you get x on the same side when you're solving equations? We want logs on the same side. We already have that situation here, don't we? Now, we need to do the reverse of your properties that you learned last week. We are expanding them. Now I want to rewrite this in simplified form. So what property was it that caused us to go to addition? Multiplication, right? So that means I combine these into one log, and it would be log of what? 4x. Isn't 4 times x 4x? How many see what I'm talking about? Yes? Because if I expand this back, wouldn't it be this? From your log properties. Remember, multiplication went to addition, so guess what addition goes back to? Multiplication. This should be common sense by now. This shouldn't be hard to understand. Now, you had this situation, it's still equal to 1. We've already done problems like this. How did we solve these log problems before? No, we only have one log. What's the base here? 10. What form do I need to write it in now to solve it? Say it again. Exponential. Write it in exponential form. You did a whole assignment on this last week. Now, I know some of you may have forgotten. I'm going to show you, but I want to see who remembers. How would I write it in exponential? Ten to the first equals 4x. The base to this power equals this. How many remember that now? We do, don't we? Okay. Now you just solve it. 10 to the first is just 10, isn't it? How do you solve that algebra 1 equation? And do not divide with a calculator. No, we're not using any calculators on this. And then you have to reduce it. So your final answer is 5/2. Everybody okay with that? All right, see if you can do number 2 on your own. Okay, number 2, I'm not going to do it yet, I'm just going to write it up here. Very similar, though. Let me add 5/3 for your answer. Easy, isn't it? All right, let's do one that's different. We're not going to do, well, we could still do, go ahead and do number 3. It's a little different. Let's try number 3. We got plenty of time here. By the way, give yourself a bonus point if you got that. If you got 5/3, give yourself a bonus point. How many are finished already? All right, I'm not going to do it yet. I want an answer first. What'd you get for an answer? Let's see what you got. Thank you. How many got 50? Okay. This is log 2x equals 2. So now we have 10 squared, not 10 to the first, don't we? 10 squared equals 2x. 10 squared is 100, right? Yes? Then you divide by 2 and you get 50. All right. Remember, you write it in exponential form. 10 to the second equals that. We're writing it in exponential form. All right, now let's do number 4, which is a little different because don't we have a log on the other side? So, number 4, we have log of 5 plus log of x equals log 24. Now these can be done a little bit easier. Now you could do it the way we've been doing it, but it's a long way to do it. How would we combine these? Yeah. I'm going to give you, there's 2 methods. This is the short method. All right. Since we have the log, a single log on both sides, and they're equal to each other, then what we're taking the log of has to be equal to each other. So I can actually take 5x equals 24. Doesn't it say the log of this equals the log of that? So wouldn't these two have to be equal for their logs to be equal?
Is that a 4 or an A?
It's a 4. So what do we do to both sides to finish it? Divide by 5 and we're done. So when you have a logarithm on the other side, combine the 2 and then you can set the logs equal. Take what they're taking the log of, set them equal, and solve that equation. Do number 6. Should be pretty quick. I miscopied that. Same thing, just a different number on the right side, isn't it? So you'll have log, and yes, you have to write this step. Some of you are thinking, I don't need to write that. Yeah, you do. You've got to show your work. Don't be lazy. Let's be mathematically correct. So then you can just take 5x equal to 78, so your final answer is 78/5, right? Everybody okay with that? All right, we're only going to do one more because it's the only one that I haven't shown you. Number 8, or number 10, excuse me. Now, give yourself a bonus point if you got that last one. All right, this is going to be worth 3 bonus points if you can do this one without me telling you how to do it. See if you can do number 10 without me telling you how to do it. Don't look at my answer over there, Brian. I saw you looking at my paper. All right. I want you to try it first. You don't know how easy I made these problems for you for this last section. Made this so easy. Excuse me. Anybody figure it out? Heather, figure it out? Derek? What does subtraction go back to? Yep. That's how we did it when we did it the other way. Wouldn't this be the same as that? Remember your log property? Division went to what? Subtraction. So guess what it goes back to? Subtraction goes back to division. Now, you can't say x over 6 equals 1. We don't have the log of both sides, do we? How do we do number 1 in your examples? Wrote it in what form? Exponential. Your base is 10. So what do we have? 10 to the first equals x over 6. X equals 60, correct. Because if it's x divided by 6, what's the opposite operation of division? Or inverse operation of division? Isn't that what you're supposed to do? The inverse division. So what do we have to do to both sides? Multiply. Have you forgotten your Algebra 1 already? Multiply both sides by 6. And you'll have 60 equals x. Or, teach sometimes to put it over 1. We have a ratio here equal to a ratio. Then you could cross multiply. 1 times x, which is x, equals 6 times 10, which is 60. All right, that's the last lesson. I'm finished teaching for the year. My job is done. Tomorrow I'll give you a review. You have to finish this for tomorrow. This is due tomorrow. Tomorrow I'll give you a review of all 3 things that we learned about logarithms, and then I'm going to give you a quiz on Wednesday over all of it. Just a second.